All right, so in this video, you're going to be solving trig functions that are quadratic. So far, you should have been solving ones that were basically linear functions or ones that had square roots or squares that you could actually undo by taking the square root. So that's considered a basic PEMDAS solving, where you're doing all your basic PEMDAS operations. Now, you're going to be solving ones that are quadratic, which is going to require factoring. So let's go ahead and do a quick review of factoring quadratics so that you are ready to solve quadratic trig functions. Okay, so factoring to solve, when you're talking about factoring quadratic problems, if there are three pieces like this, A, B, C, three pieces, we solve these by sum and product. Okay, so or product and sum, depending on how you stated it. Some of you may have seen teachers use an X, and they would put the product, and the product is always A times C, the coefficients. In this case, it would be -2, and B, which is your sum on the bottom, which in this case, the coefficient of the middle term is 1. And then you have to come up with two numbers that multiply to give you your product and add to give you your sum. Okay, so in this case, what multiplies to give you -2 and adds to give you +1 would be +2 and -1. Okay, so what we do is we take those two numbers and we split the middle term into those two numbers. So what you end up with is x squared plus 2x minus 1x minus 2 equals 0. Okay, and then from there, again, there's two options depending on what you were taught when you were factoring. You have what's called the grouping method, where you would group the first two terms and the last two terms, and then you would take the GCF out of each one. Okay, and then the other method is the box method, and this is the one that I normally taught my algebra kids, just because we also use the box method to multiply, and it kind of made more sense, where you take all four of your terms, 1, 2, 3, and 4. And then basically what you're doing is you're trying to figure out what multiplied, because this is a area model for multiplication, what multiplied to get you each of those area sections. So the x squared, you have to multiply x times x to get x squared. And then for the 2x, well, since you're already multiplying, see, this side is x, what does this side have to be to multiply to get it? Has to be a +2. Okay, and you go down to the next one. All right, so you're already multiplying x from up here times what to give you this area? That's going to be a -1. And then, of course, -1 times 2, right? -1 times 2 will get you that -2. So your two factors would be x plus 2 and x minus 1. If you did the grouping method, again, you're going to get the same answer. You're taking out the GCF of both sets of parentheses. So what's common between x squared and 2x is just an x. And if you take that out, think about like the distributive model, what would you have to multiply to get back to x squared plus 2x would be x plus 2. Okay, and then you look at the next parentheses, what does -1x and -2 have in common? All they have in common is a -1 because they're both negative. And again, distributive model, what would you have to multiply by to get back to it would be x plus 2. And as long as these two parentheses matched, then you were good to go, because your answers, again, would be one for the outside and then that one for the match. Again, it's a distributive model. You multiplied x minus 1 times x plus 2 to get your original problem. And you see that on our box method as well. So x plus 2 and x minus 1. Either method, whichever one feels more comfortable to you and whichever one you understand better, is the method you're going to want to use. Once you get it down to its factored form, you then take each piece, because it is equal to 0, and you have to solve them individually, because basically what you've done is you've taken a quadratic problem, an x squared, and broken it down to two linear problems that you can actually solve very, very easily. So your answers here would be x equals 1 and x equals -2. All right, so let's try one where a is bigger than 1. Again, just as a reminder, because you will have to do that with solving trig functions that are quadratic as well. Okay, so same process, product and sum. Okay, so my product, again, is always A times C, those two coefficients. So my product is -2. And my sum this time is -1. Okay, so what multiplies to give you -2 and adds to give you -1? So in this case, it's -2 and +1. Okay, so we're going to rewrite it. We're basically just splitting the middle term into these two pieces. So -2x plus 1x minus 1 equals 0. And no, for those of you who are wondering, you don't have to put the 1 in front of the x. I'm doing it to show that those are the actual two coefficients. Okay, so same deal. You're going to either do the grouping method or you're going to do the box method. Either one. Okay, so 2x squared minus 2x plus 1x minus 1. If you do the grouping method, again, you're taking out the GCF. What does 2x squared and -2x have in common? They both have a 2x. What you're going to multiply reverse distributing by to get back to the original would be an x minus a 1. Please be very careful. That is the piece that most people leave off. They forget that you actually have to multiply 2x times something, even if it's a 1, to get back to your original number. Okay, and then 1x and -1, well, they don't both have a negative this time, so the only thing you can take out is a +1 because they have nothing else in common. And to multiply to get back to that, you would multiply it by x minus 1. So what you have now is that you multiplied 2x plus 1 times x minus 1. Same thing if you do the box method. There's only one catch on this. To get 2x squared, we know we have to multiply 2x times x. The goal is, where do we put the 2x and where do we put the 1x, right? Because I have to get a 2x squared or a 2x in both of these two pieces, the 2x has to go here, right? And then just the plain x or 1x has to go here because I can't multiply. If I put 2x at the top, I can't multiply 2x by anything to get 1x, right? We're trying not to get fractions and stuff. So basically, you're just going back and filling in the rest of it. 2x times what is going to give me -2x, has to be a -1. And then x, right up here, times what is going to give me 1x, that's just going to be a 1. So same thing, you've got 2x plus 1 and x minus 1 for your two factors. So then you have to solve each of them independently since you now have linear problems. Okay, so you set each piece equal to 0 to solve. So 2x plus 1 equals 0, x minus 1 equals 0. Go ahead and subtract 1, and then you're going to divide by 2. So x is equal to -1/2. And here you're just adding 1, so x is equal to 1. Now you're going to do the exact same thing with trig functions, okay? And they factor the exact same way. So we're just adding words in there. That's all we're doing. So let's see what this looks like. Okay, so we have sine squared x plus sine x minus 2. If you ignore the words, this is legitimately like factoring x squared plus x minus 2. Okay, and that was our first example that we did on the previous page, right? X squared plus x minus 2. It is legitimately the same problem. The only difference is you'll obviously have an extra step at the end when you get it down to x equals a number, because then you have to go back on your unit circle and look for where sine is that number, right? By doing the inverse like you did the first day we started solving. So go ahead and we'll break it down. We'll do the product and the sum just to make sure you've got it. But here your product is -2, right? 1 times -2, and your sum is 1. So that is 2 and -1. So if you were to rewrite it with the words, and again, you don't have to, you can factor it without the words and then throw the words back on at the end. It's not actually going to change anything. Okay. So think about how it factored on the last example. Again, if you want to do grouping method or you want to do box method, it does not matter. These sine squared x and 2 sine x actually do have a sine x in common, right? And if you were to multiply to get back out, now this is something that you need to remember when you're talking about trig functions. This is not sine x times x to give you sine squared x. Notice it is not the x that's actually squared. It's the sine that's squared. So in order to get sine x squared, or sine squared x rather, you have to multiply sine x times sine x. Okay? You have to multiply the sine times the sine to get the part that's actually squared. Okay, and then you have to get a 2 there. So see, that would actually distribute back out to the original. And then same thing on this one. We already knew from the last one that -1 was what they have in common. And to multiply it out, you have to multiply sine x plus 2. Right, so that would be your grouping method. And you do the same thing in your box method, realizing that in order to get sine squared x, you have to multiply sine x times sine x. This is the way it works. So then we've got sine x minus 1 equals 0, and sine x plus 2 equals 0. So now let's do our linear solving. Add 1 to both sides, and you've got sine x equals 1. Right? And since we're trying to solve for x, we're trying to solve for the angle where this is happening, we do the sine inverse of both sides, remember? So x is the sine inverse of 1. So what it's asking you is where on your unit circle does sine equal 1? Okay, and there's only one answer. Okay, so for the other one, you'd have sine x equals -2. Again, take the inverse of both sides to get x by itself, and sine inverse of 2. So both of those are asking the same thing. Where on your unit circle does this happen? We talked about this when we were doing regular solving. Okay, so where does sine x equal 1? Well, the answer is 90 degrees or pi over 2. Depending on which you're being asked for, the radians or the degrees, you should always be ready to give both. So we should always, check it and make sure we've got our coordinates. Now for the other one, where does sine equal 2? Well, there is no place. The biggest number you're ever going to get on the unit circle is only going to be +1. Okay, so that one is basically just a no solution. So this whole problem, I know it's a lot, only has actually one answer, 90 degrees or pi over 2. Now, on a side note, I don't know if y'all remember this, back when you were doing this in Algebra 1 and even in Algebra 2, what you were trying to find when you were factoring was x-intercepts, right? I mean, think about a quadratic problem. When you solved it by factoring, you were looking for where it crossed the x-axis. This is exactly the same thing, okay? So this is, if you were to graph this quadratic trig function, this is where it would cross the x-axis. Now, there's a big thing that you need to remember, okay? Remember that these are periodic functions. We talked about this in Unit 1. They have a pattern that repeats, okay? So if all I want are answers, let's say, from 0 to 360 degrees or from 0 to 2 pi, I'm done, right? But if I want all answers, because again, this function will repeat over and over and over because it's got that symmetry and that pattern. That's the whole point of these trig functions. What we do is we write it in a very specific way, okay? So it's going to either be 90 degrees plus 360 degrees n being basically any integer, 1, 2, 3, and negative numbers and all that stuff, but specifically integers, right? Because it has to be whole numbers, right, that you have to multiply by. Multiplying by a fraction wouldn't help. But basically think of it like your coterminal angles. So it would be like 90 and 450, and I could keep adding 360, or I could keep subtracting 360, and I would keep getting that same place, okay? And if we do it in radians, it's the same thing. It's pi over 2 plus 2 pi n. All right, and this is specifically if you're being asked for all answers. Because of the way the functions work, it's going to repeat in that same place every single time. If I only want answers from 0 to 360 or 0 to 2 pi, I'm done. I can just list 90 degrees or pi over 2. Okay, so let's try another one. Okay, so now we're going to try one that has an actual number in for a, which does make a little bit of difference when you're factoring it, if only because your product gets a little bit bigger. All right, so let's go ahead and try product and sum. So in this case, my product is -6 and my sum is -1. So what multiplies to give me -6 and adds to give me -1? Should be -3 and +2. Now, if you didn't get that immediately, it's okay. You can always write down all the pairs that multiply to give you -6 first, and then find the pair that works. The good part about quadratic trig functions is you're not going to get a whole lot of really large numbers, right? And you're also not going to get a whole lot of different numbers. I mean, think about your unit circle, right? There's only so many specific coordinates that are on there. Okay, so you can only get certain numbers. So your numbers when you're factoring are never going to be that difficult. But if you need to, just write down all the pairs that actually give you -6. Be sure to change your signs every time, because remember, if it's negative, one of those numbers has to be negative. Okay, so there's all 4 of your pairs that actually work to multiply to give you -6. And the only one that actually adds to give you -1 is that pair, the -3 and 2. All right, so let's go ahead and write it out. So 2 sine squared x minus 3 sine x plus 2 sine x minus 3 equals 0. All right, and again, either by box or by grouping, your choice. And this time I'll go ahead and actually set up the box just to make sure you're good for those that prefer this method. So 2 sine squared x minus 3 sine x plus 2 sine x minus 3. Okay, so what has to multiply to give you 2 sine squared x? Okay, we know we have to have a 2 sine x, and then we also have to have a 1 sine x. So kind of like that same situation here. It's a question of where does the 2 need to go and where does the 1 need to go? That's the biggest thing. Okay, so in order to make this work, the 2 sine x has to go on top, and the 1 sine x has to go here, right? That's the only way you can multiply to get the positive 2 sine x on the bottom. So that's going to be a 1. That's going to be a -3. You get the same thing if you factored here. What do these two have in common is just sine x, and that's going to be 2 sine x minus 3. These have nothing in common, so we take out a 1, and that's going to be 2 sine x minus 3. So either way, your answers are sine x plus 1 equals 0, and 2 sine x minus 3 equals 0. All right, solve them out. You get sine x equals -1. Do the sine inverse, and that means that x is equal to the sine inverse of -1 this time. And here, add 3, divide by 2. You get sine x is equal to 3/2, which means x is equal to the sine inverse of 3/2. Okay, so very, very similar to the last problem. This does not exist. This is not the same thing as the square root of 3/2. Do not make that mistake. 3/2 is bigger than 1, and you are never going to get an answer bigger than 1. It does not work. So that's no solution. And of course, where does sine equal -1? It equals -1 at 270 degrees, or 3 pi over 2. Okay. So same thing, if I wanted all the answers, then I would do 270 plus 360n, or 3 pi over 2 plus 2 pi n. And some people will use a k to indicate an integer. N and k, I think, are the two most common. I don't think I've ever seen it written as an x, because x is used for solving. So you might see n, you might see k. All right. So that's it as far as regular factoring. I do want to show one, just because this does happen sometimes when we get into some higher level problems. So this one, okay, well, first off, it does not have 3 pieces, right? It only has 2. And this is not a problem where I can like add cosine to both sides and divide by 2. It's not one of those problems, right? It's not a linear problem, because you still have that squared piece. So it's still quadratic, but now I don't have 3 pieces. So literally the only way that I can factor this is by using the GCF. Okay, so I have to take the greatest common factor out of both of these. So it's a lot like factoring by grouping, right? That's basically all you're going to do. So they have a cosine in common. So if you do that, what would you have to multiply to get back? You would have to multiply 2 cosine x and then minus 1. Don't forget, like I said before, you do actually have to multiply that by something to get a negative cosine x. All right, it's as factors it's going to get. So basically, you're just going to set each piece equal to 0 and solve it like we would before. All right, so this one's already set. So we just do the cosine inverse. So the cosine inverse of 0 and add 1, divide by 2. I'm going to get cosine x is equal to 1/2, which means the inverse cosine of 1/2 is what I want. Now, I'm actually going to get 4 answers here. Okay, not very surprising. A lot of these problems tend to have a lot of answers because there are, that symmetry around your unit circle. So where does cosine equal 0? Well, remember that cosine is your x coordinate. It equals 0 at 90 and 270. Oh, I shouldn't write it like that. All right, so 90 and 270. Or if I'm doing this in radians, pi over 2 and 3 pi over 2. Okay, and then where does cosine equal 1/2? Okay, and again, in degrees, this should be 60 degrees and 300 degrees, right? Because cosine is positive in quadrants 1 and 4. And in radians, that would be pi over 3 and 5 pi over 3. Okay, and if we wanted to list out all of them, yeah, we'd have to write it 4 times. So in this case, I'm just going to write in radians. So just to give you the example, so if I want all in why am I writing pi? All in radians. Okay, then it would be pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n, pi over 3 plus 2 pi n, and then 5 pi over 3 plus 2 pi n. You have to write it out 4 times because, again, if you were to graph this thing, this is where it is hitting the x-axis every single time. It's a lot of answers. Okay, so the next video is going to be about higher level solving, which includes some substitution from something else that we've already learned. And that is it for today.